Okay, excuse me. Welcome to Chapter 4. Chapter 4 looks exciting. We're multiplying decimals. And again, I think this is going to be something that you guys can do a great job at. The first lesson is one of my favorites, 4.1 Multiplication Patterns with decimals. All right, so we're just talking about patterns here. And I'm going to show you a pattern just to start off with. We're going to multiply by 1. Then we're going to multiply by 10. Then we're going to multiply by 100, and then we're going to multiply by 1,000. And it's important for you to remember that let's start here. 10 is 10 to the first, and 100 is 10 to the second power, and 1,000 is 10 to the third power. Remember that 10 to the third power is the same as 10 times 10 times 10. Which is 1,000. So you see this 3 up here, you know that it's a 1 with 3 zeros. You see a 2 up here, you know it's a 1 with 2 zeros. And you see a 1, a little 1 exponent, it's a 1 with 1 zero. So this is 10 to the third power. It's sometimes called 10 cubed. This is 10 to the second power. It's sometimes called 10 squared. Now those are the only two that have kind of a special name. And we see those in area for the squared and volume for the cubed, and that kind of makes sense if you think about it. All right, so this is kind of the pattern here, and if you know that this is the pattern, can you figure out that 1 is 10 to the what? 10 to the 0 power. And you might already know this too. It is something that we need to know. Anything to the 0 power is 1. It's not just 10. 10 to the 0 power is 1, but 3 to the 0 power is also 1. And 19 to the 0 power is 1. And pi, which is a fun number, to the 0 power is 1. Anything to the 0 power is 1. So that's something to keep in mind as we go forward here. Okay, so now we're going to multiply all of these numbers by something exactly the same. So we're going to multiply, let's just make up a decimal here. Let's go 0.37. Okay, so we're going to multiply all of them by 0.37. And there's a pattern that happens, and so that's kind of why I'm writing it out this way, because the pattern is easy to see, but it's nice to kind of see it all come together at the same time. Okay, so we're going to multiply everything times 0.37, 37 hundredths. Now when you multiply by 1, you know that nothing changes. It's the same. When you multiply by 1, it's just 0.37. That's the easy one. Multiplying by 10, it gets bigger. It's 10 times bigger. And the nice thing about our system of decimals is that when you get 10 times bigger or 10 times smaller, you just move a decimal one time. And if we want the answer to get bigger, we're multiplying by 10, so it gets bigger. It's going to get bigger in the direction to the right. The decimal will move one place over. So it's 3.7. See, 3.7 is 10 times bigger than 0.37. And we come up to the 100, which is 10 to the second power. There's a 2. There's 2 zeros. So we're going to move the decimal place how many times? Yes, twice. Okay, 2 decimal place moves gives us the answer 37. Okay, and you guessed it, 3 decimal places here for 10 to the third power, or times 1,000. 1,000 times 0.37 is 3 decimal places. And don't let this cause you problems, because I can only go 2. I can only go 2. What do I do if I need to go 3? Well, you just have to add a placeholder. So instead of 37 hundredths, this becomes 370 thousandths, and your answer is just 370. Okay, so you have to put a 0 in here to hold the place. You don't have to actually write it. You can actually do that in your head, but the decimal's going to have to move 3 places. That's the important part to remember. Now that's all this lesson is about. This is what they're going to do over and over again. The problem is they're going to give you some that look a little different. Instead of just giving you 1, 10, 100, and 1,000, they could switch the order around. They might say 1.94 and put the 1, the 10, and the 1,000, or the 100 and the 1,000 on the right side instead. Well, you're going to do the same thing. It's just going to feel a little different because the numbers are swapped. When you multiply by 1, you're still multiplying by 1. Okay, we have 1.94, 1.94, 1.94 all the way across. I'm trying to go fast so that you don't get bored. You still are not going to move the decimal at all when you multiply by 1. It's going to stay the same. Anything times 1 is itself, the identity property. And multiply by 10, that's 1 place value. So that's 19.4. Multiply by 100, that's 2. So it's 194. And here it's 3. And again, you need to add that 0. You don't have to actually write it here, but that's what's happening. There's an extra place value that gets used. So it's 1940. Okay? You got to add that here because you've moved it over 3 times. So just think about this. If you had to multiply 1 times 1,000, you'd get 1,000. So here we have 1,000, but it's a little more than 1,000. It's 1,940. Well, it's because we had 940 thousandths that were sitting behind the 1. So this is less than 2, but it's almost 2. And this is less than 2,000, but it's almost 2,000. And hopefully, if you pay a little attention to this, that all of this will start to make sense. Something that I've noticed is that red and this magenta color do not look good together. We're going to try not to do that again. Erase that from your vision. Okay, they are going to do other things, though. They'll just give you instead of the 1 and the 10 and the 100, they're going to give you 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. So you're going to have to work with that, but remember it's the same thing. I think the hardest thing that they're going to do is they're going to ask you to use decimals, which is sort of the opposite, and they don't exactly explain it, so I'm going to explain it. They may do something like this: 1 times 452, and then 0.1 times 452. So this number is staying the same, but this is doing the opposite. Instead of multiplying by 10, 100, and 1,000, it's multiplying by 1, a tenth, and a hundredth. And I guess we could go one place farther to the thousandth place. So what happens when you multiply by something smaller than 1? This is 10 times smaller than 1, so this is 1/10 of the number. So your decimal place is actually going to go the opposite direction. So 452, if I multiply by 1, it's 452. I should have changed colors. If I multiply by 1/10, your decimal's going to actually go the other way. And you might be saying, Mr. Armstrong, there's no decimal on that problem. Well, 452 doesn't have a decimal shown, but there is a decimal there. It's like there are no hundredths, and there are no tenths, there are no hundredths, and there are no thousandths. You don't actually need to write these numbers to know that they're there. They're there forever. There's zeros that go on to infinity if we want to use them, because they don't really have meaning. Okay, right now, in this number, they don't. They don't have any value because there are no hundredths or tenths or thousandths, etc. But we can still, even though there's no decimal showing, we can still move our decimal one place. And we're going to move it to a place that makes our number smaller. Okay, so 452 is 10 times bigger than 45.2. See, it's 10 times smaller because we multiplied by a number less than 1. Now, this is kind of a hard concept. When we multiply, we actually get a smaller answer. Doesn't multiplication mean it should always get bigger? Well, yeah, but when we multiply by a number smaller than 1, it doesn't. Now, remember, we went through this. Like 1 times a number, say 5, is 5. It's the same. 10 times a number 5 is bigger. It's 50. And so it keeps getting bigger as we go on. 100 times 5 is 500. But what happens if we get smaller? This pattern can go in reverse. 0.1 times 5 is 0.5. See, it's getting smaller. And 0.01 times 5 is 0.05. It gets even smaller. And that pattern keeps continuing. 1 is a magic number. 1 is the most important number. Well, that's not the most important number. 0 is probably just as important. But in math, the number 1, you could say that number 1 is number 1. It's one of the most important numbers. Maybe the most important number. For some reason it comes up and it does crazy things all the time. So back to this one. This one we multiplied by 0.1 and we moved the decimal one place. So if we multiply by 0.01, we're going to move the decimal two places. And we have to move it this direction to the left because our number is going to get smaller because we're multiplying it by 100th. It's getting 100 times smaller. So it's 4.52. Can't get it to write. There we go. And then this one is 0.452 because we have to move it 3 times. 1, 2, 3. Because there are 1, 2, 3, a thousandth. It's a thousandth, so it's way smaller. Now, the only other thing you need for this lesson is to figure out what to do with n. They gave you some crazy problems where you have to figure out what n is, like n times 3.14 equals 314.0. Okay, so what happened here? Well, the decimal got moved to get from here to here. The decimal moved 2 places. It moved 2 places to land over here behind the 4. So what would I have to multiply to get it to move 2 places to the right? I'd have to multiply it by 100, or 10 to the second. So n is either 100 or it's 10 to the second power. These are the same. So n times, so 10 to the second times 3.14 is 314. Okay, there's one example. They give you another one where they do something like 0.1 times n equals 34. Okay, 34. What would you multiply? Oops, I wrote equals. Let's fix that. I said times, I think, but I wrote equals. 0.1 times n. So you're going to multiply 0.1 times something that equals 34. And you have to figure out what that is. Well, since you're multiplying times 0.1, it gets 10 times smaller. So what's 10 times bigger than 34? 340. And then we're going to write it out and look at it and see if it works. If I multiply 0.1 times 340, then I'm actually going to move my decimal. Remember, the decimal you can't see unless you add a decimal. Unless you add a decimal and a 0, then you can see it. Move it one place over, so it's 34.0. So this could be 34.0, or it could just be 34. They're the same thing. Okay. The only other example is something like 10 to the third times n equals 452. So you're making something 1,000 times bigger, because 10 to the 3 is 1,000. It gets 1,000 times bigger. Whatever n is, gets 1,000 times bigger to equal 4.452. 452. So we're going to move the decimal 3 times smaller. It has to be smaller so that when we multiply it, it gets bigger again. So we could imagine moving this decimal 3 places to the left and see if that works. So 0.452. Does that equal 452? So is 1,000 times 4.452 equal to 452? My handwriting's going down. I'm trying to go quick because I know we're running out of time here. It does. If I move the decimal 3 times, it equals 452. So n must be 0 and 452 thousandths. Okay? All right, that's it for today. You guys have a nice whatever you got going on tonight or this morning, whatever it is you're doing. I hope you enjoy it. If you want to stick around, I'll draw a little something. Okay. So, Mr. Armstrong. He's had a very good time. He's on vacation right now. That's me. Okay, I'm on vacation right now, and I'm enjoying myself. One of the things I'm doing more of is I'm working out more. I'm enjoying my time. I'm getting a little exercise, a little more than I usually get, and it's creating a happy Mr. Armstrong. Okay. There's happy Mr. Armstrong. And I want to tell you, I've been going to the gym, and it's been kind of fun. And it's been interesting just going to the gym. I've been going to the mall. Well, I don't go to the mall. I go by the mall. And this is kind of the interesting part. And you can see it's starting to take shape. I'm taking myself to the mall, or by the mall, because I have to go by the mall to get to the place that I work out. Well, this isn't turning out very well. My feet are not looking like normal feet. Well, we'll just kind of pretend, okay? But as you can see, I have kind of this neat little toy. It's a little scooter type of thing. And I take it and I just zoom from my house, kind of through the mall. Sometimes I just go right inside the mall. And, kind of have to go, it's kind of a little hard because you have to take the escalator downstairs to get from my side of the mall to the other side of the mall. And sometimes the security guy chases me. But I go through the mall and across the street over by the Target, and there's a little athletic center there where I work out. So it's kind of fun because I get there and I'm already warmed up and I can just start working out right away. And they got a little parking for my scooter, and I got a little locker inside. Anyway, it's lots of fun. I hope you're doing something fun for your vacation too. Or I hope you did, because by the time you watch this, your vacation will be over.